Hi guys, in this episode of Shri series, we're going to be talking about calculating physics questions involving force and power. Alright, so let's look at this question here and I'll read it out here for you. A 125 kilogram windsurfer takes advantage of a sudden increase in the wind speed, accelerating from 4.85 meters per second to 7.40 meters per second in 3.3 seconds. Calculate the force and power of the wind applied to the windsurfer. All right, so before we go any further, it's important to highlight what relevant information has been given. All right, so we've got 125 kilograms, so that's my mass. All right, and we know that due to that wind speed, there's actually acceleration from 4.85 meters per second to 7.4 meters per second in 3.3 seconds. Calculate the force and power. All right, so let's highlight the relevant information down here. We got a mass which is 125 kilograms. We've got our initial velocity which is 4.85 meters per second. We have our final velocity as 7.40 meters per second. We've got our time as 3.30 seconds. All right, so the reason why I get students to write down what information has been given is you'll be able to find out what formula to use. All right, now when you look at force, all right, how is this relevant to the question? Okay, so there's a force being exerted, and what formula links force? All right, we know that there's mass and then there's also acceleration from the question. All right, so if you remember this formula, F is equal to ma. To me, this formula is apt for this question. All right. Now, we know very well that acceleration is V minus U over T. All right. So what I can do is in place of A, I can use V minus U over T because there is final velocity, there is initial velocity, and there is time. Okay, so what I'll do now is I'm going to substitute. So F is equal to M. My M is 125 and I know what my V is, so that's 7.4 minus 4.85 divided by 3.3. all right, now that's going to be my force, and I'm just going to get my calculator to work that out. So 7.4 minus 4.85 divided by 3.3, and I'm going to multiply it by 125, and you're going to get 96.6 newtons. All right, so that's the force with which you've got wind applied to the windsurfer. All right, so we've got F is equal to ma, and then A is V minus U over T. We literally substitute in the formula. The next thing we now need to work out is power. All right, we've got power in this situation. So let me rub this out and work through what is required to solve power. Now, if you looked at my previous videos, I actually showed you the connection between power, energy, and time, or power, work, and time. The reason why I say this is because the unit for work is equal, or it's also the same as the unit for energy, which is joules. All right, so if you look at the formula here involving power, we know very well that power is work over time. We've got our time, which is 3.3 seconds. Now, if you look at work, we know the formula for work is force times distance. Now, in this question, we can't see distance here. If there was distance, I would have gotten the force, which is 96.6, multiplied it by my distance to get my work, and divide it by 3.3. But in that case, that is not there. What we can do is we know very well that work is in joules and so is power. But we can see also here that there is mass and there is velocity. There's initial and final velocity. So in my mind, what comes is when you have mass and velocity, you use what's known as kinetic energy. So our W can be solved by calculating the change in kinetic energy, because kinetic energy is in joules and so is work. All right. So what we can do here is we have what's known as a change in kinetic energy, which is half mv squared final, which is F for final, minus half mv squared, which is initial. All right, so that's what I would do in this situation. So if you see carefully, we can factorize half m. So that's half m v squared minus u squared. All right, and that's going to be half 125, because that's my mass, 7.4 squared minus 4.85 squared. All right, what do we get in this situation? So that's 7.4 squared minus 4.85 squared multiplied by 125 and divided by 2. All right, multiplied by 125 and divided by 2, and I'm going to get 1952 joules. 1952 joules. Now, that's not my answer, because what we have got is work. We now need to get power, and to achieve or obtain power, we need to divide 1952 over the time. So what I'll do is I'll put an asterisk here just to show you where we proceed from this question. So power is work over time, and P becomes 1952 divided by 3.3 seconds. All right, divide that by 3.3 and you're going to get 592 watts. All right, because we know very well the unit for power is watts. All right, so we've calculated the force, which is 96.6 newtons, and we've calculated the power, which is 592 watts. So you can see that sometimes you might get a question where you may be asked to combine forces, acceleration, power, and kinetic energy. So you can see that this question requires not just understanding velocity or acceleration, but you need to find out the connection between work and the connection between energy, because a lot of students sometimes get confused. They would say, all right, I need to get work, and I know work is force times distance. I've got my force, but I don't know how to calculate my distance. But then you realize, no, hang on, the unit for work is also the same unit for energy. And if you look at the situation here, we've got the mass, which is 125, and you have your initial and final velocity. So in your mind, you know that there's movement. All right, so therefore there's kinetic energy. There is a change in kinetic energy. All right, final minus your initial. All right, and that's how you get your work, and then eventually divide it by your time to get 592 watts. All right, thanks for listening, guys. Bye now.